Right, so today we're going to be talking about radioactive half-lives. So to start off with, a real quick thing, radioactive half-life is defined as the amount of time it takes 1/2 of a radioactive sample to decay. So, as the name would imply, after one half-life, you have half of what you started with. Seems pretty simple, and that's exactly what it is. So moving on to some simple problems here, real quick. So from page number 808, this is question number 10. Just what we went over. How much of a sample of radioisotope remains after one half-life? Well, if you think about what we just said that a radioactive half-life is the amount of time it takes 1/2 a sample to decay. So one half-life equals 1/2 of the starting amount. So how much of a sample would remain after one half-life? 1/2 of the sample would remain after one half-life. And after two half-lives, we just double it. So what's 1/2 of 1/2? That is 1/4. So that's how much would remain after two half-lives. This system keeps applying throughout all the problems we'll do. So this one gives us, from page 808, number 13, gives us radioisotope has a half-life of 4 days. How much of a 20-gram sample remains at the end of each time period? And then we're given 2 time periods. So at the end of 4 days, well, we would think half would remain, right? So what I like to do is make a little table. I have my half-life. So at half-life 0, we started with 20 grams. And at half-life 1, we'd now decreased to half of that, which is 10 grams. So we would have 10 grams left after 4 days. This is the same thing, but 2 times. So I'll draw out my little table again. I'll abbreviate half-life and amount. 0 half-life, we have 20 grams. 1 half-life, we have 10 grams, which would mean at 2 half-lives, we would have then again half of that, as we stated on our page over here. 2 is just a half times a half, which is a quarter. So we would have a quarter of 20, or a half of 10, which is 5. That's how much would be left. So as you can see, these really aren't that hard. Now we'll get into ones that are a little bit more advanced, but they're still nothing too hard to do. So the half-life of thorium-227 is 18.72 days. That's important. We're going to need that. Grab a handy dandy. We're going to need that. How many days are required for it to reach 1/16? So this time we're not actually dealing with amounts, we're just dealing with the fractions. So I still like to set up my table for this, but instead of an amount on the right side, I'm going to put a fraction. So I'll set my table, half-life, 0. We have a whole, so 1. This will be our fraction. We have 1. After 1 half-life, we have a half. After 2 half-lives, we have a quarter. After 3 half-lives, we have half of that, or an eighth. After 4 half-lives, we have half of an eighth, or 1/16 of the original amount. So it would take 4 half-lives. So then all we have to do is plug this back into our formula here. So we know that 1 half-life takes 18.72 days to complete. So if we have 4 half-lives, then all we have to do is multiply our half-life time by how many half-lives we've had. So I'll break out my little calculator here, and we'll put in, we have 4 half-lives at 18.72 days per half-life. Should give us how many days? So we can see here that it is 74.88 days for it to reach 1/16 of the original amount. So it will take 74.88 days. And then if I was answering a test question, I'd probably continue and say it takes that many days to reach 1/16, but this will do for now. It will take 74.88 days. So I want to show you something too that you may be asked, which is actually really similar. If we have this, they could also ask this same question, but in a percentage form. And if you'll notice, it's exactly the same question, except they're asking us for a percent rather than a fraction. So we do this the same way, except we're going to have a half-life number and a percent number. To do this, I'm going to set up our table and repeat exactly how we did. Half-life 0, we have 100%. Half-life 1, we have 50%, or half. At half-life 2, we have 25%, or 1/4. At half-life 3, we have 12.5%, or you can see the fraction for that would be 1/8. At half-life 4, we would have 6.25%, or 1/16. So you can see these all line up. I'll put percentage here. So if you look at our two tables, we still got the same answer. It would take 4 half-lives, which if we multiplied out, 4 times 18.72 would also give us 74.88 days. So you can see it's exactly the same thing, but just using percentage. And if we look at our table, they match up, and it's the same thing. You're just using percentage rather than fractions. And if you get confused, you could even convert between the two of them. So the last kind of problem I want to do real quick is a reverse problem, which really we should know how to do if we've taken algebra, but I just want to go over it. So this gives us the reverse. It gives us, we started with 5 milligrams, and we ended up with 0.625 milligrams. So we're just going to go down. So we're going to determine how many half-lives it takes, and then we'll divide our amount of years by our half-lives to get how long one half-life is. So going on the list, 5 milligrams is half-life 0, and our amount. Half-life 1, we have 2.5. So half-life 0, we have 5. And then I'm going to go into the calculator now to make sure I'm doing this correctly. Then we have 1.25 at half-life 2. And we have 0.625 at half-life 3. So we can see it took 3 half-lives. Now using simple math, if we just divide 4797 by 3, that will tell us that each half-life takes approximately 1,599 years. So I hope this video helped you. You now should be able to solve all the half-life problems you need and understand what it means, and I thank you for watching.